Hello everyone. So this is my Count Squares ML project. The objective is to use machine learning to count 3 to 10 squares in different configurations. So first, the training data. I used 1,000,000 synthetic images. Each image is so large with white squares and there's gray outlines to each square. The data split is 800,000 for training, 100,000 for validation, and for testing. So the model, I used a 5-stage convolution encoder. You can see what that would look like down here. So the encoder goes down to the latent space and that gets interpreted, and the decoder interprets that to a number. So I use regression as my prediction type. So instead of classification where it's like classified as, oh, this number is 3, 4, 5, 6, it instead has a continuous prediction. So it might be 6.69 or 0.39, and then that gets converted into a number. So loss and optimization, used cosine annealing scheduler, which means that it starts large and then it gets smaller and smaller so that you fine tune your predictions. Data augmentation. So I have 1,000,000 images, but you can create more images just by slightly flipping them, warping them. Early stopping in case it doesn't improve. So the results, I had 96.2 accuracy, and the mean error loss was very small compared to just a random baseline of 12.5%. So now the fun part, let's go into the demo. So, So here we have demo set 6, and it's going through the images. There's only 50 images in each set. But as we can see, the accuracy is pretty good, even though a lot of these images are fairly complicated. Let's see if we'll just go through all these images. And then we have 98%. We go to the next set. But yeah, that is my project so far. My next steps will be trying to find the corners of the squares. And once we find the corners, it'll be a lot easier for pick and place operations and such. Basically, I want to make a pipeline of different machine learning algorithms that you can modularize, and that way development is easier.